Hello everyone. Let's understand the definition for the terms iterable and iterator. Before I dive into the actual definitions, I just want to mention one quick thing about both of these terms. Even experienced programmers often mix up the definition for iterable with the definition for an iterator. That's because both of these terms have similar names. Please make sure to understand the difference between both of these terms clearly. Hopefully, I should be able to do a good job of explaining each of these terms in the next few slides. Let's focus on the term iterable first. Whenever you have a for loop which has the format for x in something, that something is going to be an iterable. Recall that you should be able to use a for loop to iterate over any kind of sequence. So any kind of sequence is going to be an iterable. List, string and tuples are kind of sequences. So you should be able to get an iterable out of all of those sequences. The range built-in function call returns a kind of a sequence. So that sequence is also iterable. Whenever you have an iterable, you should be able to convert it into a list because of this cyclic relationship over here. I have an example for that. I have a string called ABC. String is a sequence. Any sequence is an iterable. So I should be able to convert this particular string into a list by simply saying list of ABC. We have covered other examples where we use a for loop. Recall that we are able to use a for loop to iterate over key value pairs in a dictionary. That works because the methods, keys and values associated with the dictionary data structure return an iterable. That is the reason why you are able to say for key in dictionary name. Dictionary is not an example of a sequence. Why is that the case? We cannot slice a dictionary, correct? Slicing is a feature of a sequence. Since you cannot slice a dictionary, dictionary is not an example of a sequence. Let's talk about the term iterator now. Whenever you have an iterable, you can get an iterator out of it. How do you do that? You'll be using the iter function call. String is an example of iterable. That's because string is a sequence. So I should be able to call the iter function on the string. What does the iter function return? It returns an iterator. What can you do with an iterator? You can call the next function on the iterator. We just now saw examples of next function calls using generator object instances. What does the next function call do? It simply gets the next value from the iterator. Let's talk about the new concepts of the generator function that we just learned. Generator function can be identified by the presence of yield statement. A generator function returns a generator object. A generator object is an example of an iterator because you're able to call the next function on the generator object. A lot of people mix up the terms generator for both generator function and generator object. We are going to be pretty clear about it though. When I'm talking about the function, I'm going to say generator function. When I'm talking about what is being returned from that function, I'm going to use the term generator object. Some programmers also mix up the terms generator and iterator. They both are totally different terms. Generator object is an example of an iterator, but iterator is a more general term. One final thing which I want to mention about an iterator is that an iterator is an iterable. It better be an iterable because we are able to use that in a for loop. Let's try and understand how we can identify whether a particular variable is an iterator or an iterable. Let me differentiate both of those for you. X is iterable if you're able to call the iter function on it. Y is considered an iterator if the next function call works on Y. What is the relationship between an iterable and an iterator? An iterable generates an iterator, and you can call the next function call on an iterator. Again, iterators are iterable. That's why you are able to use a for loop on an iterator, and that's why you're able to use the next function call on an iterator. Let's go through each of these examples using Jupyter Notebook. I'm going to copy paste the first example here into my notebook. Let me switch to my notebook. You'll notice that I already have questions about each of these examples in the template notebook file. Let me paste the first example here. X contains a reference to a list object, correct? Clearly X is iterable. That's because list is a type of a sequence. But how can we confirm whether X is iterable? You can call the iter function on it. So since the iter function call works, X is iterable. Is X an iterator? How can you verify that? You can use the next function call and pass X as an argument. The next function call throws a type error saying list object is not an iterator. That's because you cannot use X as an iterator here. So I'm going to go ahead and comment this and leave a note saying X is not iterator, an iterator. How can we get an iterator for X? We can capture the return value coming out of the iter function. Let me capture that into a variable called it. That's going to be the most common variable name that you'll use for iterator. And this is common across many programming languages. We can call the next function on an iterator, correct? So now I should be able to call the next function on it, and that's going to give me the first item because this is the first time I'm calling the next function on the iterator it. What will happen if I call the next function again? I'm going to get 2, which is the next item. I should be able to call it one more time, which should give me a value of 3, which is the third item. What will happen if I call the next function one more time here? That's going to throw a stop iteration exception. This is similar to what we saw with the generator object example, correct? When we try to call the next function on a generator object instance which has already gone through the entire generator function execution, you get the same stop iteration exception. In next lecture, we'll be talking all about exceptions. For now, just try to understand that you cannot call the next function once you're done iterating using an iterator. So I'm going to go ahead and comment this line and say that this throws stop iteration exception. Let's go through the next example. The next example has a function call called enumerate. We don't really know what that function call is supposed to do, but even if you don't know what it is supposed to do, you can still tell whether Y is iterable or it is an iterator. You can simply call iter function using Y. If that works, then Y is an iterable. So let me leave the note here. We can check if Y is an iterator by calling the next function on it, correct? That is also working. So clearly Y is also an iterator. So let's try and understand what exactly the enumerate function here does. So I'm going to capture the return value of the iter function call into the variable called it. I'm going to use it to go through the next function calls instead of directly using Y here. What is the first function call to next giving me? It's giving me a tuple of two values. It's giving me 0 and 1, correct? So it's giving me the first item and the index corresponding to the first item over here. So if I call next of IT one more time, that's going to give me the values 1, 2. Let me go ahead and add the next function call in the same line so that we can keep seeing the output of all of the next function calls. If I call it one more time, that's going to give me the values of 2 and 3. So what is the enumerate built-in function doing? It's giving me the index associated with each item along with each of those items. Let's go through one more example of enumerate built-in function to understand the function clearly. Instead of using a list of integers, I'm going to use a list of strings where I have 3 string values A, B and C. Let's go through the same example here. What is the first function call for next giving me? It's giving me the first item A and also the index of that item, which is index 0. So what is going to happen when we call the next function call one more time? That's going to give us the values of item B and the associated index, which is going to be index 1. If you call the next function one more time after these 3 function calls, you're going to again get stop iteration exception. Let's go through this last example over here. We have a variable called z, which contains a reference to an integer object called 3. Is z iterable? Are you able to call the iter function on it? Sorry, I used the wrong variable name here. You're not able to call the iter function on it because the built-in objects are not iterable. They are not an iterator either. Let me demonstrate that to you. So I can say this is not an iterable. I can show that z is not an iterator by calling the next function on it. For primitive types, you are not able to iterate over them using a for loop, so neither of these will work. Let me switch back to my slide deck over here. I'm going to provide you a brief introduction of the open built-in function call, which enables you to open a particular file and read contents from it. We'll be covering more details about this function call as part of next Monday's lecture. Let me go through an example. Whenever you want to read a file, you typically define a variable called path, which contains the relative path to that particular file, correct? And then the built-in function open enables you to open that particular file. Since we have a function, let's talk about input and output. The input to the built-in function open is simply going to be the variable path, which has the relative path to the file that you want to open. What is the output out of the open function call? It returns a file object. File objects are iterators. Because file objects are iterators, you should be able to use a for loop, and you should be able to write a for loop of the format for line in f, where f is the file object. This works fine because the file object f is an iterator. I'll not be going through any of these demos. We'll cover demos as part of next week Monday's lecture. That will be it for today's lecture.